Hello, welcome back. Today we get to talk about determinants of matrices. We've seen determinants before in the case of 2 by 2s. The determinant of the 2 by 2 is the AD minus BC that we divide by in finding the inverse. So sometimes we denote determinants with vertical lines around them, or sometimes in the matrix form we just won't write those little square dashes on the brackets. Alright, so additionally with determinants, the way that we're going to define them is piece by piece. So let's start by defining the minor. So the minor of a square matrix is the determinant of the matrix that you get when you remove one of the rows and one of the columns of the given matrix. So we'll denote this by Mij, so ith row, jth column. And now the determinant of the n by n matrix is given by an alternating sum of scaled versions of the minors. So notice I missed an A, 1, N, in the end. So what you do is you go through the first row of your matrix A, and you multiply the value of that matrix by the minor. Alright, so continuing on, let's go ahead and do an example where we actually compute this. So let's take the determinant of this 3 by 3 matrix here. So when taking the determinant, we'll follow this formula here, and notice I've written out the first three, so we can just use those. So we take the first entry, here in this case is 0, 0, sort of delete the first row and the first column, and we take 0 times the determinant of the 2 by 2 matrix that remains. So that'll be the first term, so that goes there, and then we'll do a minus. Let's erase all this so that we can get back the determinant when we take the second entry, delete everything. So we get a -1, that's our A12, times the determinant again of what's left, so this time it's 4, 5, -1, 2. Alright. And then plus, let's erase again, we get 1 times what's left. 4, -1, -1, 4. Alright, so that would be 0 plus, let's see here, 4 times 2, 8, AD minus BC, plus 5, plus 1 times 16 minus -1 times -1 would be a 1. Alright, so we add these together. 8 and 5, that's 13. 16 minus 1 is 15, and so we get 28 as our determinant. Alright, let's continue with the second example. Here we have a 4 by 4 matrix. It has a bunch of zeros in it. And we may have noticed in the first example how powerful the zeros were. So we could go across this first row like we did in the first example, but notice it only has 1 0 in it, which is sort of a bummer. We want to be able to use more than that. So in fact, what we can do is we can work down, say, this third column. Right? And it'll work just the same, so let's mark out. So the matrices have this plus minus alternating pattern, checkerboard style, in every single row and column. And so if we want to expand down the third column, we get a plus minus there. And so we're going to have our determinant. Really, actually, we've already denoted that. So our determinant is plus 0 times something, minus 0 times something, plus 0 times something, minus 4 times something. Alright, so let's erase those pluses and minuses so we can have more space. So I know we're multiplying by 0, but let's just get the practice in of writing down what the minors are. So we cross out everything in the row and column of that 0. We get 0, 1, 0, 0, 0, 3, 0, 0, and 2, negative 1, negative 1. Oops, I wrote too many zeros, didn't I? That's why we practice this. Alright. Excellent, so that's our first one. Let's continue down to the second one. Again, we are multiplying by 0, but let's get the practice in. So we have negative 1, 2, 0, 3, 0, 2, negative 1, negative 1. Alright. Third one, also multiplying by 0, is going to give us negative 1, 2 again. 0, 1, 0, 2, negative 1, negative 1. Alright. And then lastly, the one that does count, we get negative 1, 2, 0, 1, 0, 0, 3, 0. Alright, so all of this stuff is going to be 0, so that's 0. So really, down here in our computation, we get 0 minus 4, and then this is a 3 by 3, so we're going to continue in our same pattern. So let's actually go along maybe the second row. So we get minus, plus, minus along the second row. So here we'll get negative 0 times something. So that would be negative 1, 2, 3, 0, plus 1 times negative 1, 2, 0, 0, minus 0 times negative 1, 0, 3. Alright, so that's 0 minus 4. Let's see, that is 0. That is 0. So 0 plus 1. And now this is a 2 by 2, so we can do AD minus BC, and we get 0 minus 0 minus 0. Alright, so a bunch of zeros. So we ended up with determinant 0. Alright, so that's pretty neat. So if we go back to our matrix before, we actually could have figured out from the beginning that we would have gotten determinant 0 because the second and third columns, or rows, sorry, are multiples of one another. So we know that if we row reduce this matrix, we'd get a 0 row. And if we think about it, 0 row leads to non-invertible. And really, the thing we want out of our matrices, out of our determinant of our matrices, is that it should give us a quick and easy indication of whether or not it's invertible. So we just got the number 0, so it is not invertible. Alright, that's all for this one. Have a good one, and enjoy!